This image is 160 million miles wide. To be more precise, it's 160 million miles across. It shows just over 10 billion stars. And if you want to get an idea of how big space really is, then this should do it. If you took this picture here of the Whirlpool Galaxy and expanded it until it filled the entire sky, so that the edge of the galaxy was at the horizon in every direction, then, when you looked up into the sky above you, you would see the same thing. You'd see billions upon billions of stars, not just in the Milky Way, but also in other galaxies. In fact, you'd see so many galaxies that it would be impossible for your brain to comprehend it. The Milky Way is a whopping 100,000 light years across. At its widest point, that's how far light travels in 100,000 years. But it turns out that's really not very far at all. Because if we take one of those stars in that photo and imagine ourselves hurtling towards it at 186,000 miles per second, which is the speed of light, it would still take us 650,000 years to reach it. That means that even if we could travel at the speed of light, it would still take us 650,000 years to reach just one of these stars. And if we wanted to cross the Milky Way, we would need to double that number, because we'd have to travel 100,000 light years in each direction. So traveling at the speed of light would take us 130,000 years to cross our galaxy from one side to the other. And that's just the Milky Way. In reality, the universe is home to trillions upon trillions of galaxies, each containing hundreds of billions of stars. And what's more, they're all moving away from each other at an ever-increasing rate. And so if we were to leave our galaxy now and try to visit just one of those other galaxies, say Andromeda, which is the closest major galaxy to our own, we wouldn't get there for another 4 billion years. And yet somehow we humans have managed to explore almost all of the places in our galaxy are reachable within 4 billion years. We've been to the Moon, Mars, Venus, Jupiter, Saturn, Neptune, and we've sent probes hurtling through space to explore the furthest reaches of our solar system. We've discovered thousands of planets outside of our solar system, some of which are probably capable of supporting life. And we've done all of this in less than 5,000 years. But just imagine what we'll be capable of in another 5,000 years. We might actually be able to explore other galaxies. The first interstellar spacecraft will embark on journeys that take millions or even billions of years. Humans may spread throughout the universe, might find new forms of life, and discover the answers to some of our deepest questions about existence. Maybe we'll find God, or maybe we won't. But let's step back for a moment and remember what we started with, because it's worth repeating just how truly mind-bogglingly huge the universe is. If you lit up every single star in the night sky, if you made every single one of them shine brighter than the sun, if you did that, then if you took a picture of it, you could expand that picture until it was 160 million miles across, and it still wouldn't show you everything. There would still be more stars beyond the picture, beyond the horizon. And if you wanted to see all of those stars, you would have to keep expanding that image until it was 2,300 billion miles across. Because that's how far away the observable universe ends. 23 billion light years from Earth. But unfortunately, that's not the end of space. We know that there's more because we can see the effects of gravity from things that we QA and see. There's dark matter and dark energy. So space goes on forever in the same way that time goes on forever. Only we can never see the beginning of time because we always have a past. And we can never see the beginning of space because we always have a beginning. In fact, the only thing we can be certain of is the small patch of space that we occupy right now. The rest of space and all of time are a mystery to us. Now, when you think of the most distant things in the universe, you might imagine things like nebulae, quasars, supernovas, black holes. But these are all just tiny specks of dust, pinpoints of light, particles of energy, faint ripples in the fabric of space-time, all hurtling through the cosmos at 14 billion miles per hour. And yes, they're unimaginably huge. But they're nothing compared to the most distant thing in the universe, which is literally the past. For example, if you look up at the night sky tonight, you're actually looking back in time. Everything you see is receding away from you. All of the stars, planets, nebulae, galaxies, They're all retreating into the past. And the further away they are, the further back in time you're seeing them. Light takes time to travel. And so the more distant something is, the longer it takes for its light to reach you. That means that if you're looking at a galaxy that is 10 billion light years away, then you're actually looking back in time 10 billion years. You're seeing it as it was when it was 10 billion years old. And that is why astronomers use powerful telescopes to look back in time and see the early stages of the universe. Take this image, for example. This is the cosmic microwave background, or the CMB. It's basically a baby picture of the universe. It's taken 13.7 billion years ago, when the universe was just 400,000 years old. This image shows us the universe as it was before stars formed, before galaxies came into existence, before planets or solar systems or black holes or quasars or nebulae existed. This is as far back in time as we can see. This is the beginning of everything. And when you realize that that's where we started from, that we evolved from this simple soup of elementary particles into stars and planets and solar systems and galaxies and quasars and nebulae and black holes and dark matter and dark energy, and that we evolved from that into conscious beings who are capable of exploring the universe, then you begin to understand how special we are. We're kind of like the universe's way of understanding itself, like a self-aware fragment of the cosmos that has broken off and become conscious. And maybe that's why we spend so much time trying to understand the universe. Maybe it's because deep down we know that understanding the universe is the same as understanding ourselves. In the end, the most important thing to remember is that the universe isn't just this cold, dead place. It's full of wonder and beauty and mystery. And no matter how far we travel or how much we learn, there will always be more to discover. And that's what makes exploring space so exciting. It's hard to describe just how big the universe is, how vast and unending it seems. When you hear numbers like 10 billion or 1 trillion, it's easy to feel like they don't really mean anything. But the truth is, the universe is unimaginably large. And the more we learn about it, the more we realize just how small we are. But maybe that's not such a bad thing. Maybe it's good to remember how small we are because it reminds us of just how much there is to learn. It's easy to feel like we've already learned everything there is to learn about the universe, that everything is just repeating itself over and over again. But the truth is, we've barely scratched the surface. There's so much out there that we don't know, so much that we've never seen before, that it's almost impossible to imagine. And that's what makes exploring space so exciting. Who knows what we might find out there? What new worlds? What new life? What new wonders? The possibilities are really endless.